If a sun-like star is a grapefruit, Jupiter is a pea, but system TOI 5205 swaps that grapefruit for a lemon. The red dwarf host star has only 40% our sun's mass, yet orbits a Jupiter-sized gas giant. A planet this large should not exist around a star this small. Its presence contradicts the basic mathematics of how we calculate planetary formation. According to our standard models, stars and planets are built at the exact same time from a shared, finite disk of leftover dust and gas. If a forming star is tiny, the disk surrounding it is also small. A star with less than half the mass of our Sun simply does not leave behind enough leftover building blocks to construct a massive gas giant. Astronomers Shubham Kanadia and Nicole Wallach launched an initiative called Red Dwarfs and the Seven Giants to investigate how these seemingly impossible worlds come to exist. To interrogate this specific system, the team utilized the James Webb Space Telescope, aiming its infrared sensors directly at the distant red dwarf. Finding a Jupiter-sized planet here proves there is a glaring flaw in our understanding of how cosmic material aggregates into planets. This diagram shows the process of atmospheric spectroscopy. As a planet passes in front of its host star, the telescope captures the starlight filtering through the planet's atmosphere, splitting it into a distinct absorption spectrum that reveals specific chemical fingerprints. When analyzing the outer envelope of TOI 5205b, the researchers found a highly carbon-rich atmosphere, marked by clear detections of methane and hydrogen sulfide. But the data also revealed a secondary anomaly, a severe lack of heavy metals. The atmospheric layer was surprisingly depleted of heavier elements. Based on this initial reading, TOI 5205b appeared to be a lightweight, metal-poor gas giant. But the atmospheric chemistry was only half the story. When the team calculated the mass and composition of the planet's deep interior, the numbers directly contradicted the atmospheric readings. This chart illustrates the extreme disparity. The planet's core is estimated to be 10 times more metal-rich than the light carbon envelope surrounding it. Gas giants in our own solar system, like Jupiter, exhibit a thorough blending of elements. Their intense internal pressures and immense heat churn materials from the core all the way up into the cloud layers. TOI 5205b shows absolutely no elemental mixing between its dense interior and its outer sky. The heavy metals are entirely locked away at the center. This strict separation of elements indicates that the planet formed through an entirely unknown physical mechanism, one that bypasses the standard rules of gas giant accretion. Because of its sheer mass and unique chemistry, astronomers cannot dismiss TOI 5205b as a simple statistical outlier. It actively breaks the established limits of planetary physics. This theoretical chart shows the historical planetary mass limit for low-mass red dwarf stars. With this discovery, that strict boundary line is being forced upward to accommodate the existence of such a massive world. As Kanodia noted, researchers must now literally turn the mathematical knobs on their computer models, stretching the parameters of physics to explain how a giant planet can coalesce in an environment with so little available material. A single anomaly has forced the scientific community to accept that our foundational framework for planetary creation is incomplete. This disruption is not a failure of science. It is the exact reason we built the James Webb Space Telescope in the first place. The rigid, predictable models printed in our textbooks are constantly being tested against the wild, chaotic reality of the cosmos. Exposing precisely where our calculations fall short is the highest possible value of modern astronomy. It points us directly toward the phenomena we still need to figure out. We finally possess the instruments required to see the universe's true complexity. And as the data from these deep space observations continues to arrive, we will have to keep rewriting the rules.